Hello, my name is Nigel Wally from Decipher, and this is one of our foundation sessions where we look at the core concepts and basic ideas that underpin the media and tech industries. Today's session is the difference between the internet and the web. In today's session, we're going to question why that's important to us in the media industry, and we're going to put it into context of the services that we in the industry present to consumers and understand how the difference in the tech background affects what consumers see on their screen. Right at the end, we're going to do just a little bit on the blockchain, because having set up the framework to look at it, it would be a shame not to throw that in and explain it as well. So first of all, the internet and the web, are they the same thing? I'm going to refer a couple of times in this presentation to this guy, Tim Berners-Lee. He often gets described as the inventor of the internet. And if we look at his own website, there's a great big section on there where he rebuts the idea that he invented the internet. So did you invent the internet? No, no, no. And these are questions he gets posed all the time. So if the inventor of the web is being very clear that he wasn't the inventor of the internet, then we know that those two ideas are different. And we'll go on later on to explain why. From the media industry's point of view, we get asked questions a lot which flag up the conflict between the ideas of the internet and the web. The most common one is the difference between on-demand telly on platforms like Sky and Virgin and on-demand telly on platforms like YouView and Freeview. And people say to us, if I go into an on-demand player in Sky, it looks fundamentally different than when I go into an on-demand player like ITV Hub on YouView and Freeview. And in fact, the ones on YouView and Freeview look much more like the websites I see on my laptop or on my phone. And the simple answer is that both of these systems use the internet, but only one of them, the YouView and Freeview, for example, use the web to deliver TV content to your television screen. By the end of the session, you'll be able to describe the difference between those two ideas and why that's the case. So as we go through this, I'm going to make the case that the web is just one kind of content that runs over the internet. And in fact, there's lots of different kinds of content that we use on a day-to-day basis. There's email, file transfer, yes, TV, and even at the end of the session, we'll explain that blockchain is one of those ideas that runs over the internet. I'm going to make the case that every kind of content, infrastructure, hardware, whatever it may be, the key thing we need is standards. Let's start off with the internet. Let's go right to the word itself. Now, I'm sure most people subconsciously know this, but the word internet is a contraction of two words, interconnected and networks. So the internet describes a global set of networks which are all owned by different people, different organizations, telecom companies, universities, government, which somehow connect together to make the internet. And to understand it, we need to go all the way back to the 50s and the 60s, when computing research looked a bit like this in universities around the world, and people were starting to explore the idea of connecting computers together to form a basic network. And the idea that if you had 4 or 5 computers together in a building, you could run cables between them and somehow create a network. And what we saw through that period were these universities around the world, governments, sometimes the military, experimenting with what could happen if you connect PCs together to create a network, and more importantly, if around the world you begin to connect networks. And there were networks in America and in Europe, all operating individually, and then eventually people started running telecoms cables across the Atlantic and connecting them together, and we began to see the emergence of this thing that we call the internet. And the key thing to get into your head is this notion that the internet describes physical infrastructure, computers, servers, routers, telecoms cables, physical things that you can see and touch, all interconnected around the world. To get there, to enable networks to be able to plug into each other, absolutely crucial is to have standards. Through this session, we're going to talk about various kinds of standards. Firstly, hardware standards. So this notion that anywhere in the world, if you've got a cable like the one on the left, you should be able to plug it into a hole like the one on the right, and for it to fit and to work and the devices to recognize each other. And that's come about because of 30 or 40 years worth of work on hardware standards. The work on the hardware standards has been absolutely crucial. Even before we start talking about content, as well as the physical hardware standards, there is also a huge amount of work on software and content standards. And we're going to talk a lot more about these content standards because the web is, in effect, one of the content standards that runs over the internet. So we're going to talk more about them as we go through. And I'm going to use the word protocols. And we're going to talk about internet protocols and web protocols. And what I mean when I say the word protocols is really a set of rules and standards for software and content to be moved across a network. And we can't avoid the fact that these protocols are absolutely crucial to what we're going to do. So let's get used to using the word protocol as we go. And all of the hardware and software protocols around the world have all been developed at this place here. This is the International Telecoms Union, which is one of the oldest international organizations in the world, based over in Switzerland. And everything we talk about today, every type of content, every standard, every protocol has been developed and standardized and worked on over millions of hours of committee time and scientific investigation coordinated by the ITU. And so when we talk about agreements and protocols, it's all agreed by this group here. So internet protocols, we're going to use the acronym IP a lot. However, in the media industry, we have to be aware that IP has got a couple of meanings. So a brief kind of diversion, particularly in the media and tech industries, there are at least two groups of people who use the acronym IP differently. There are obviously the lawyers and the creatives, and there are the techies. For the lawyers and the creatives, IP means intellectual property. Who owns the right to a piece of content, or a piece of creative, piece of artwork. And for the techies, of course, it means, as we've described, internet protocol. And I flag this up, you just need to be aware that the acronym IP gets used differently by different groups in our industry. And also be aware that you may end up in some meetings where the acronym IP with both meanings gets used interchangeably. So we've talked about the internet as this global network of computers and cables, all based around a group of previously agreed standards. And we're now going to talk about kinds of content that you can run over the internet. We're going to talk in a moment about these 5 kinds of content that you can run over the internet. But before we do, just to reiterate this notion of protocols, for each of these 5 things, I'm going to make the case that there has to be a standard set of protocols for them to work over the internet. So we're going to talk about the need for transfer protocols. For any of those kinds of content, an email, a piece of file transfer, some web content, one of the core ideas we're going to talk about is transfer protocols, and that's transferring between networks, as we see in the diagram, but also transferring between your devices and the internet. Just downloading something from the internet requires protocol. And at the same time, each of these content types requires computers out on the network that recognize the content and know how to hold it and know how to serve it up to the rest of the networks. And then finally, on our devices, PCs on our desks, our phones, our iPads, there has to be some software running that understands that process as well. And so when we talk about those 5 content types, I'm going to talk about transfer protocols, the servers, the local software that relates to each of those types of content. So let's start off with file transfer and this guy, Abhi Bhushan. So Abhi Bhushan, one of the unsung heroes of the internet. Abhi Bhushan was a very well-renowned network technologist working at an Indian university. And he had this great notion that has become an important building block in the internet, that it will be a really good thing to be able to package up huge files of data and move it simply across a network. And if you've ever had to send anybody a huge, great presentation or compress a load of photos to move across a network, then you're using technologies that Abhi Bhushan first laid down in 1971. And he was working at a time when computers looked like this, big clunky old things, and they had for a few years been connecting them via telephone lines, both within buildings and across campuses. And his great idea was that if you could compress data into much smaller blocks and blocks that could be recognized by the network, then you could move things very easily across what would become the internet. And as we know from the previous slides, if you want to do anything on the internet, if you want to create any new form of content, you need a protocol. So Abhi Bhushan sat down in 1971 and he wrote a transfer protocol for big files and what we now know as file transfer protocol. So if we just go back into the slides. So when we look at how it fits onto our diagram, he wrote file transfer protocol. He wrote the first definition of what an FTP server might look like. So servers out on the internet that were able to capture and hold and then transfer big compressed files of data. And he wrote the first software to sit on a PC. So he wrote the first FTP software. So anytime you send somebody a huge, great document over the internet, you're probably using one of Abu Gushan's original core ideas for the internet. Now, you may, on your PC, be running some FTP software like FileZilla or Fetch, and they are the most common FTP software that people use. And he developed them all the way back in 1971. But I'm guessing a lot of people out there are saying, no, hold on. If I ever need to send somebody a great big document, I go to a website. I don't use software on my PC. I go to a website like WeTransfer or You Send It, or one of those sites where I can upload a huge, great document. And I'm going to ask you just to hold that thought for a minute. I'm going to make the case that you are using Abu Gushan's software and his ideas, but you're going to be doing it through a website. So hold that thought. I will come back to it because I want to talk about this guy. So, Ray Tomlinson, again, one of those unsung heroes of the internet. Back in 71, he had a really simple idea. He wanted to send a simple text message from one computer to another over a network. And he laid out what became the foundation of every email system we use today. As we know from the previous diagram, if you want to do anything with content on the internet, you need to write a protocol, transfer protocol. So back in 1971, Ray Tomlinson wrote a transfer protocol for what he called simple messaging. And this transfer protocol, SMTP, became the foundation on which services like Outlook and iMail are built on today. And most of us probably don't see that acronym on a day-to-day basis. But if you open up your phone and look in your iMail settings, or if you open up Outlook or any of the email systems you run on your PC, what you'll see right in the core there is a request for an SMTP number. And this is Ray Tomlinson's original foundation for email. As we know, as we said at the beginning, if you want to run content over the internet, it's got to have our three things. It's got to have servers, protocols, or software. And all the way back in 1971, he wrote SMTP, as we just said, the simple mail transfer protocol. He designed the very first mail server as a computer to sit out on the internet to hold and manage emails. And he wrote the very first email software program. So I'm sure people have used Outlook or Apple Mail or any of those software programs. You are using something created by Ray Tomlinson all the way back in 1971. So the best part of 50 years ago. Again, people are going to be out there saying, hold on, did I use a website for my email? I use Yahoo Mail or I use Hotmail. And I'm going to say to you the same thing, hold that thought. I'm going to come back and explain how you're using a website. And again, I'm going to make the case that in reality, you're using Ray Tomlinson's idea, but just hidden behind a website. Finally, we get to this guy again. We saw him earlier on, Tim Berners-Lee. Back in the late 80s, Tim Berners-Lee was working as a research scientist at a United Nations facility in Switzerland, CERN, C-E-R-N, and he was looking at the explosion of content out on the internet, predominantly academic content. And he saw as networks got added to the internet around the world, the internet itself was exploding, the amount of content that was out there and available to be found was exploding. This is before search engines, we must remember. And he had this great insight as well. And his great insight was that nothing links together. And if we just illustrate what he meant, let's imagine out on this new global internet of content, somewhere out there is a computer connected to the internet with content about France. We have a huge amount of information about France, and somewhere in the text that's holding about France, let's, for instance, suggest it may have some information on the Eiffel Tower. At the same time, on the other side of the world, on another network owned by a different organization, is a server full of content about towers. And in there, it also mentions the Eiffel Tower. So two computers on different networks owned by different organizations for different reasons around the world, both mentioning the Eiffel Tower. Tim Berners-Lee's great insight was we should connect them somehow. We should flag up that both those bits of information refer to the Eiffel Tower. And his simple idea was that we could maybe illustrate that with the text on the screen by having the text a different color and maybe an underline. And if you saw that text with a different color and underline, you could click on it and it would show you the other information around the world that related to the same subject. Because he's a sci-fi buff, Tim Berners-Lee called this linking hyperlinking. It's a Star Trek reference, and he called the text that it sat in hypertext. So hyperlinks and hypertext were Tim Berners-Lee's great insight. And as we know, you have to write a transfer protocol for anything you want to run on the internet. And so he wrote hypertext transfer protocol. So anywhere you go on the internet, if you see HTTP, hypertext transfer protocol, on a web address like that, you know you are somehow playing with Tim Berners-Lee's original invention for the web. And that simple thing, hypertext, led to this global concept that has changed the world, the World Wide Web. Hugely influential invention, all coming from that one insight of one man. As we know, for any invention to run on the internet, you have to have these three things: servers, protocols, and software. And Tim Berners-Lee sat down at his desk in CERN and he wrote in a single document a definition for all of those things. He wrote the original definition for hypertext, and he wrote a description of how a web server would hold and serve content written in this hypertext he'd invented. And he wrote the very first specification for a piece of software to sit on a PC for you to use to go and find and use that information. So he wrote the code for the very first browser. And he put it all into a block of information. And in his biography, he describes how he took this document and he posted it on the internet for comment. So his very early definition of the web was posted on the internet for comment. So we know those two concepts are separate because one was posted onto the other. If you've used any of the software packages like Netscape, Internet Explorer, Chrome, Firefox, etc., you are using modern versions of a software idea that he came up with all the way back in 1989. So the question is, what was that stuff we were talking about earlier on? People saying, hang on, I use a website to transfer files, or I use a website for email. And there's a broader question which relates to that, which is how did the web come to dominate all discussion about the internet to the point where the two phrases were synonymous? Now, clearly, as we've described, you can use a web browser for browsing web content. That's what they do. But very quickly, people flagged up that it was quite complex to run software on your PC to transfer big files. I mentioned FileZilla and Fetch, and probably a lot of you listening to this don't have that software on your PC. It's also very complex to set up and run email software. So you may have on your work PC a copy of Outlook, but maybe on a personal PC, you just run webmail, Yahoo or Hotmail or something similar. And the reason that came about was there were companies who recognized how complex it was to run those bits of software on a PC, and they set up a service where they ran it for you on their PCs and offered you access to their content and their software from a web browser. So with file transfer, we mentioned something like WeTransfer or YouSendIt. What you're doing is you're using those companies' websites as a window to look into the software that they're running for you on their computers. So whilst on your PC you're just using a web browser, you are using Abu Bushan's FTP software on someone else's PC. Same thing for mail. If you're using Yahoo Mail, etc., you're using a web browser as a window to look across the network at some software that's been run for you on the PCs of the email service provider. And so they're doing the hard work. So there we have the internet versus the web. We've talked about the internet as physical infrastructure, and we've talked about the web and email and file transfer as content types that can run over the web. So are they the same thing? No, they're not. However, we can say quite clearly, no, they're different. The web runs on the internet. The web is just one kind of content you can run on the internet, but there are other kinds. And having dealt with email and file transfer and basic web, we shouldn't forget that we're here also to talk about TV and a bit of blockchain at the end. So let's go back to hypertext transfer protocol. There's a word in there I want to focus on, which is text. When Tim Berners-Lee originally wrote the code to run the web, he was only thinking about text. He wasn't thinking about pictures. He hadn't thought about including pictures at all. And he most definitely wasn't thinking about running Last Night's Coronation Street into an app on your phone. He definitely wasn't thinking about video and telly. But as we know with any invention, as soon as a thing is invented, people start extending it, seeing what they can do with it. And in this instance, Tim Berners-Lee himself recognized that if he wanted his new world of hypertext to support academic publications, he had to include illustrations. So he himself almost immediately started working on how to include images into web pages. And he was at CERN, and their in-house band was called Les Horribles Cernettes. So here we have the Les Horribles Cernettes, the horrible Cernettes. And this was a fun in-house band made up by a group of scientists working with Tim Berners-Lee at CERN. And they had taken a photo for a gig they were doing in the research place. Tim Berners-Lee needed a photo. And so he borrowed a photo from the Cernettes. So this is the very first photo that he ever managed to encode in a web page. So the very first photo on the internet. And of course, he was then able to write that into the core internet code, and it became a standard thing. If you were building a website, you could have text and you can now have images. The Cernettes, you'll be pleased to know, still meet, still play gigs. Here they are, a couple of years ago, playing a gig, and you can see this gig on YouTube. It's there in video. Now this raises an interesting point, because having extended his own text code to include pictures, so hypertext could now include images in the code, people then started looking at whether video could be included. Now there's a very different element to video than photos, and obviously it's movement. A web page is a snapshot of a set of information at any one time. So the leap to include a picture wasn't a huge coding leap, because you could show a static picture alongside static text. Video, however, was much more complex because it involves movement, it involves live dynamism, etc. And what we found was, for about 10 years, there was a huge kind of battle about how to include video in the web text. So any of you who remember these dreadful things popping up on the screen, saying that if you wanted to play a video or an animation on a web page, you had to have the right plugin in your system. And you may remember all those wars about Apple devices refusing to run Flash because Apple and Steve Jobs didn't like Flash. That whole mess came about because it was too hard to include video code within the original web code. Which leads us into a question, how the TV industry managed to get going with online video and on-demand video. And what happened back in the late 90s was that the TV industry, looking at our diagram, began to get interested in whether they could run TV and video over the internet. They, for all the reasons we've just described, found the web as a coding mechanism to be much too complex and fallible to run good TV over. But they did like the idea of connecting set-top boxes to the internet to run video in some form. And so what we saw was, around the world, different telecoms companies and different television companies work on a proprietary set of servers, protocols, and software to create some form of internet-delivered video. So the notion of a video server came into our life as the telecoms industry worked out proprietary ways of doing it, and we saw proprietary servers and protocols and proprietary software being built into set-top boxes start delivering television over the internet. And way back in 2000 and around the time, we saw the launch of a few services that use the internet completely to deliver a television service. Probably the longest lasting and the most famous was Home Choice, based in London, and they use the internet to deliver broadcast channels as well as on-demand programs and movies and music videos. It was a very popular service and very innovative very early on in its use of its own proprietary protocol. And we saw that eventually bought by Tiscali and turned into Tiscali TV. And we saw BT launch their first generation television service, BT Vision, which was also using their own BT proprietary protocols and software. And what we ended up with was a bit of a Wild West landscape where every telecom or television company that was using these services around the world had developed their own proprietary protocols and set-top box software and servers, and were running their television services in parallel over the internet into this private lockdown environment. And we never really got to the point where we started to see standardization around a television and video protocol. About 7 years later, we saw Sky launch their own on-demand service in the UK, and Virgin followed suit very quickly. And again, these companies, big established TV companies by this point, were using software, servers, and transfer protocols, which were their own proprietary protocols. And they really stayed with us in that form as television has taken off. What we saw, though, through the early 2000s and leading up to 2006 was a lot more work looking again at whether it was possible to weave video into Tim Berners-Lee's original HTTP hypertext idea for the web. And eventually, by 2006, we started to see the launch of proper web video ideas. And we started to see web servers out there. And initially, just running television services into web browsers on our PCs and early laptops. And so we saw the launch of 4OnDemand, ITV Player as it was, BBC iPlayer. And as I say, these were just targeted initially at PCs running web browsers. And then very quickly, after 2006, when smart devices arrived, TV services moved out to smart devices and eventually into set-top boxes. And by 2009, we saw smart televisions, which were really just big iPads by this point, running web apps with web video services from the major broadcasters. And at this point, we had these two parallel kinds of television video being delivered into our homes, the existing IPTV services and the new web services. I must say, I don't like the phrase IPTV because it meant something in the early days before the arrival of web video, but now it's a phrase which kind of describes all video over the internet. So all television services delivered as over an internet protocol should be covered by that service. But sometimes it still gets used to refer to the old original kind of television services versus the web services. So I prefer not to use that acronym because its meaning has become slightly fuzzy. So if we look at where we are now, there are services out in the market which still run the old proprietary video-based services. So Virgin is a good example. Most of the on-demand on Virgin still runs using its proprietary video protocols. There are services out in the market like Freeview and Freeview Play that are running web apps into a full television service. Same thing, Sky, still using the proprietary video service that it launched back in 2007, but at the same time, we have web-based services, in this instance, YouView, that run web apps into a TV set-top box and or smart TV. We look at the different definitions, proprietary video versus web video. As we said right at the very beginning, both of these services run over the internet. Only one of them, the YouView service, uses the web to deliver its content. Why do it? Why are the platforms still running proprietary video services as opposed to web? They would say, and we would have some sympathy with this statement, that they are able to still deliver a better video quality over the proprietary video services. And also they can offer through their set-top box software a more consistent experience across all broadcasters. So the experience of using ITV on a Skybox is very similar to the experience of using Channel 4, etc., both in terms of layout and functionality. Those companies that offer web-based TV services like Freeview, like YouView, they will say that they offer better functionality. So they're able to bring lots of the functionality that's been developed for the web up into their TV services, which hasn't been the case over on the proprietary platforms. And they're able to offer a more consistent experience across all devices. And what they mean by that is that ITV Hub looks and feels on the TV very much in the same way as it looks and feels on a PC or a smartphone. So two different messages about the contrasting experience of proprietary internet and web video out on TV. When we look to the future, the reality is that these worlds are coming together, and it's likely that we will have services that run both kinds of video into the same set-top box or the same TV screen. The dirty little secret in the background is that we're already there and have been for quite a while. So if you know Virgin, for instance, if you compare ITV's player on Virgin to the BBC's player, you'll know that ITV and Channel 4 and all of the other video players run Virgin's proprietary on-demand system using Virgin's proprietary servers, transfer protocols, and set-top box software. But in the Virgin system is BBC iPlayer. BBC iPlayer on Virgin is very much a web app. So Virgin for a long time has been able to run too. If we look at some of the newer and emerging TV systems, Sky Q, for instance, all the catch-up content, all the on-demand movies, etc., with some caveats, still run on Sky's proprietary internet video code. But when we look across their service, they are letting apps in like YouTube, Netflix, and more recently Disney Plus, which are very much full web on-demand services, and their apps look and feel very similar to the way they do on a laptop or an iPad, which tells us that in the Sky set-top box, there is code running which can speak both languages. There is still a significant block of code in the Sky set-top box that talks to its own proprietary video servers using its own proprietary protocols, but somehow they've managed to weave into a Skybox more web capability, and so somewhere in there is some form of web browser that can speak to Netflix, YouTube, and Disney Plus. And so that combined future is probably where we are going to be with most TV services over the next few years. And if you look at the BBC on Sky Q, they're actually running both. First time we've seen both. So most BBC catch-up content in the main catch-up menus, which is the left-hand picture, is running in Sky's proprietary on-demand code. But delve deeply into the BBC area, and you can see the picture on the right, which gives you access to the BBC's full web player through the Sky service. So what do we know? I think we've established that the web and the internet are different things, obviously very closely related things. We know that the internet is a description of physical technology, things we can actually see and touch, servers, cables, routers, etc. Whilst the web is a description of the kind of content that runs over the internet. And we know that the web is just one of the kinds of content that you can run over the internet. And that on a day-to-day basis, all of us use lots of different kinds. All of us will use email, we use websites, we may send files over file transfer systems. And I think now that we can say that we know every different kind of content we want to run over the internet requires its own code, its own protocols, its own servers, and very often its own software on our PCs and mobile devices. But there's a few services like email, like FTP, where we can actually use a website to shortcut the use of the software and run it through. And that's really it. That's the sum total of the difference between the internet and the web. I did promise one extra little thing at the end. Blockchain. This word has bubbled up into our life over the last few years, along with products you can build on the blockchain, like Bitcoin. And so how does blockchain fit into this story that we've just laid out? If we go back to our diagram, we can make the case that blockchain is just another of the content types that runs over the internet. We will be running a later session wholly on the blockchain and its implications for the media industry. But just a bit of background, why did we end up with a new kind of content on the internet? There was lots of research, particularly by industries like the financial services industry, in creating new kinds of content that could run over the internet that had some characteristics that none of the other content formats were able to deliver. So they wanted content that could never be erased, a permanent record. Whereas we know you can erase a website and and emails and things. But the financial services industry wanted records that were, to use a word they use a lot, immutable. They wanted records that were additive. So there was always a record of things that had happened before. And this is the background to the word blockchain. They wanted the ability to add in a block of data and add it to an existing chain of blocks that made a long-term record of whether it covered transactions or any form of record, whatever it may be. They wanted a form of content that enabled them to create this chain of records. And security. They wanted something which was secure enough to enable innovation around finance and new legal products. And probably the first one that you'll be aware of is Bitcoin. So Bitcoin was a new kind of financial product, a new currency, as it were, that used blockchain technology to deliver this new consumer outcome. And we'll talk more about that in the session that we run specifically on blockchain. But all we really need to know for the minute is that the blockchain is another kind of content. As we've said all the way through this, for any kind of content run on the internet, you need our three things: servers, protocols, software. And the problem we have with the blockchain is that it's in a very similar position to video content was way back when we saw the launch of IPTV. Lots of different companies developing their own proprietary protocols and trying to establish them as the standard. There's 6 or 7 major companies with very different approaches to how the blockchain could and should work. So when we talk about defining the servers and the protocols, we are putting question marks over it. And it may be that there is never one definitive outcome. We'll have to wait and see. For now, all we need to know is if someone says the blockchain, what's all that about? We can say it's just another kind of internet content, runs alongside the web, runs alongside the email. It's got its own unique characteristics and its own protocols and standards. And that's everything at this stage we should be able to say about the blockchain. It's just another type of internet content. As a final thought, don't forget to subscribe to the Decipher Off-Air YouTube channel, and we look forward to seeing you at the next session.